Most of us grew up learning there are three main types of matter: solid, liquid, and gas. Today, we've created an entirely new state of matter: topoconductors.
Our first quantum processor based on this architecture is the Majorana 1.
Quantum computing has been hyped for years, but here's the reality. Most quantum computers today are fragile, error-prone, and nowhere near practical use. That's why Microsoft's latest breakthrough is making headlines. They've just unveiled Majorana 1, the world's first quantum processor powered by topological qubits, a game-changing technology that could finally make large-scale quantum computing possible. For decades, scalability and reliability have held quantum computing back. Now, Microsoft claims they've cracked the code with a completely new approach that could change everything. But is this a real breakthrough or just another overhyped tech promise? Stick around because we're breaking down exactly how this technology works, how it could impact you, and how it stacks up against Google and IBM.
The knowledge of quantum mechanics, together with Einstein's theories of relativity, really gave us the modern world.
Why quantum computing hasn't worked until now. Quantum computers use qubits, which are like superpowered versions of the zeros and ones in regular computers. But instead of being just one or the other, qubits can be both at the same time. This makes quantum computers way faster at solving certain problems than normal computers. But there's a big problem. Qubits are extremely sensitive. Even the tiniest disturbance like heat or radiation can mess them up and cause errors. To fix this, companies like Google and IBM use quantum error correction, which means they group lots of qubits together just to keep one qubit stable. But this isn't practical because it takes millions of qubits to make just a few useful ones. Microsoft is doing something completely different. Instead of using tons of qubits to correct errors, they built qubits that don't need as much fixing in the first place. These are called topological qubits, and they could be the key to making quantum computers actually work on a large scale. The first topological quantum processor. Microsoft's Majorana 1 processor uses a new type of qubit called a topological qubit, which is much better at avoiding errors. At the heart of this breakthrough is a special material that Microsoft created called a topoconductor. This material helps form a unique state of matter that allows for the creation of Majorana zero modes, ZMs. These are tiny, strange particles that can store quantum information in a way that makes them naturally protected from outside interference. This solves one of the biggest problems in quantum computing, keeping qubits stable. Because topological qubits don't get messed up easily, they don't need a ton of extra qubits just to fix errors. This means quantum computers can be built with far fewer qubits, making it possible to fit millions of them onto a single chip. With fewer errors, these computers can do more accurate and reliable calculations, making them much closer to being useful in the real world. For years, Majorana zero modes were just an idea in science books. But with Majorana 1, Microsoft has actually made them work in real hardware. This is a whole new way of building quantum computers. How Microsoft's quantum processor actually works. One big question about Microsoft's topological qubits is, if they're so well protected, how do you even read the information inside them? The answer: quantum dots. These are tiny parts inside the chip that store and sense electrical charge, acting like mini detectors for quantum information. Here's how it works. Each qubit is connected to a quantum dot that checks whether the number of electrons is even or odd, kind of like counting marbles in a jar. Then, microwaves are used to read this charge without disturbing the qubit. Since topological qubits are naturally stable, this method is way more reliable than how most quantum computers do it. Another cool thing? Microsoft's system is fully digital, while most quantum computers still use analog controls that are more fragile and error-prone. Digital control means simpler operations, fewer mistakes, and the ability to scale up easily. Instead of delicate, fine-tuned adjustments, Microsoft uses simple on-off switches, just like regular computers, but applied in a whole new way for quantum computing. This shift could be the key to making large-scale quantum computers a reality. Microsoft's roadmap to a million-qubit quantum computer. The real challenge in quantum computing isn't just making a new type of qubit, it's making millions of them work together. A handful of stable qubits won't change the world, but if we can build millions, we could unlock real-world applications like discovering new medicines, making super powerful AI, and solving problems no regular computer can handle. Microsoft has a step-by-step plan to make that happen, moving from small experiments to a fully functional quantum supercomputer. It all starts with something called tetrons, Microsoft's basic single-qubit device made from 2 topological nanowires. Once that works, the next step is 4 by 2 qubit arrays, an 8-qubit system that will test out full quantum error correction, basically making sure the qubits can fix their own mistakes. After that, they'll move to a fault-tolerant prototype, a much bigger quantum processor that can handle real calculations without constantly messing up, something regular quantum computers struggle with. But the real goal? 1 million qubits. Right now, Google's quantum computers need millions of qubits just to keep a few stable because their system is so fragile. Microsoft says they don't have that problem. Their topological qubits are naturally stable, meaning they need far fewer qubits to do the same job. In fact, they claim their qubits need 10 times fewer resources than traditional quantum computers. This makes everything simpler, faster, and more practical, not in 50 years, but possibly in just a few years. If they can pull this off, quantum computers could finally become a reality much sooner than anyone expected. DARPA's involvement. One big sign that Microsoft's quantum computer could be a real game changer is that DARPA, a US government agency that funds high-tech cutting-edge projects, is backing them. DARPA is known for supporting some of the biggest tech advancements in history, like the early internet and GPS. And now they've picked Microsoft as one of only 2 companies to move forward in their US 2QC program, which is basically a test to see if quantum computers can actually be useful on a large scale. Microsoft's topological qubits pass their tough requirements, which is a big deal. DARPA's support matters because it means Microsoft's quantum technology isn't just a cool idea on paper. It's actually working. DARPA doesn't waste time on things that don't have real potential, and they've teamed up with top research institutions like NASA Ames Research Center, Los Alamos National Laboratory, and Oak Ridge National Laboratory to take a deep look at what Microsoft is building. These are the kinds of places that work on super advanced science and technology, so their interest shows that Microsoft's approach could be one of the best chances we have to make large, stable, and useful quantum computers a reality. And that leads to the biggest question: what happens when we actually reach a million-qubit system? Could quantum computers finally change the world? Real-world applications of a quantum supercomputer. A quantum computer with 1 million qubits wouldn't just be a cool science experiment. It could solve some of the world's biggest problems. Even today's most powerful supercomputers struggle with certain tasks, like simulating tiny molecules or predicting how new materials behave. But a large-scale quantum computer could handle these problems much faster and more accurately, leading to breakthroughs in medicine, energy, cybersecurity, and AI. In healthcare, quantum computers could revolutionize drug discovery by simulating how molecules interact. Instead of spending years testing different drugs, scientists could use quantum simulations to design new medicines in weeks, possibly finding cures for cancer, Alzheimer's, and rare genetic disorders much faster. In climate science and energy, quantum computers could help develop better batteries, improve solar energy efficiency, and even design self-healing materials, meaning buildings, bridges, and even spaceships that could repair themselves when damaged. This could lead to safer infrastructure and more sustainable technology. In cybersecurity, today's encryption is based on hard math problems that take classical computers too long to solve, but a quantum supercomputer could break them in seconds, which is a major security risk. At the same time, quantum technology is also creating new encryption methods that could be unbreakable, protecting digital data in the future. Quantum computing could also transform AI and machine learning. Right now, training AI models takes months because it requires so much computing power. But quantum computers could train AI in minutes, making self-driving cars, voice assistants, and medical AI much smarter and more efficient. Microsoft believes that if they can build a fault-tolerant quantum computer, it could change entire industries. And with DARPA backing their research and a clear roadmap, they might be closer than ever to making this a reality. How Microsoft compares to Google and IBM. The race to build a real, working quantum computer is heating up. Google, IBM, and Microsoft are all competing to see who can make it first, but they're using very different strategies to get there. Google made big news in 2019 when they claimed something called quantum supremacy. Basically, their quantum computer solved a problem way faster than a regular supercomputer could. But there's a catch. Google's system needs millions of extra qubits just to fix its own errors. This makes it really hard to scale up to a useful quantum computer. IBM has been improving its quantum chips, called Eagle and Condor, but they still use superconducting qubits, which have the same error problems as Google's. That means IBM also needs tons of extra qubits just to keep things stable. Microsoft, on the other hand, is trying something completely different. Instead of using more and more qubits to fix errors, they design topological qubits, which are naturally more stable, making them easier to scale. If this method works on a large scale, Microsoft's quantum processor could be more efficient, more reliable, and easier to build than anything Google or IBM has made so far. The race to build the first true quantum supercomputer is still wide open, but with Microsoft's new breakthrough, they might just take the lead. What's next? Microsoft claims they are only a few years away from building a fault-tolerant quantum prototype. While quantum computing is still in its early stages, this could be one of the most significant technological revolutions of the century. If Microsoft's Majorana 1 processor delivers as promised, they could be the first to crack the quantum code, achieving reliable, large-scale quantum computing before anyone else. What do you think? Is Microsoft leading the future of quantum computing? If you've made it this far, let us know what you think in the comments section below. For more interesting topics, make sure you watch the recommended video that you see on the screen right now. Thanks for watching.